Today we're going to be talking about electrical resistance as well as the Ohm's law. So basically what resistance does is the opposition to the flow of electric current. So we already talked about current is the letter I and is measured in amperes. We're now talking about resistance, which is R. If you remember, what is the unit to measure resistance? Anybody? Okay, is measured in ohms. Okay, so basically what a resistor is, it slows down the electrons. Okay, everything, including light bulb, motors, obviously resistor, all materials will have some sort of internal resistance, and things that has a high internal resistance will produce more heat. Things that have a low resistance will produce less heat, right? So we wanted to use copper wire in our house because it has a relatively low resistance, so it doesn't waste a lot of heat while the electrons are going through the household for you to use your electricity. But things like iron, we probably wanted to use material like nichrome, which is you know the ironing board, the one you iron your shirt. I don't know how many of you iron your shirt or your skirt or whatever, because resistance really high, it heats up. Okay, so there are these things called a resistor. We already talked about the symbol for a resistor. It's like a little wiggly line like that. It's our electrical devices that are specifically made with specific resistance value so that we can do testings and stuff. And they're using a lot of different electronics appliances as well. And we have these things called the variable resistor that allows you to change resistance. So things like dimmer at home, like that's what you would be using, a variable resistor to allow you to change the resistance. Okay, so what do we use to measure resistance? Just like current, we use an ammeter. Voltage, we use a voltmeter. I think as obviously as it says, ohms meter, because resistance is measured in ohms. Ohm meter is used to measure the resistance. So you would need to know what it looks like. So it has a circle with a symbol of an omega. And they are also wired in parallel. So you would notice that if this is the light bulb and we wanted to measure the resistance across the light bulb, we have to connect an extra path. That's what parallel means. And the other thing is you have to make sure that the circuit is turned off. And that's why when we were doing our gizmo, you were told to take out the battery and then hook the resistance on it. I don't know if you remember. It has to be, the appliance have to be off in order for your resistance to work. Okay, Ohm's law is the mathematical relationship. And basically they're telling you that voltage is proportional to current. And that's where this equation comes from. V equals I times R. And if we put it in a magic triangle, V is I times R. You see how I is beside R. And if that's the case, we would put I and R beside each other. So to rewrite this equation, okay, we already have the first equation is V equals to I times R. How about if I want to look for I? Okay, so remember, I'm going to go through the magic triangle with you again. If I have, let's use hexagon. Okay, what color? Turquoise. Okay, if I want to cover up the I see V at the top, R at the bottom. Oops. So I'm going to write V at the top and then R at the bottom. Okay, if I want to change the question and say if I want to look for R, so I'm going to cover up the R, see what I have left. If I want to find R, V is at the top, I is at the bottom. So that's the three different ways to write your equation. Okay, the chart is helpful. This should add on to the chart that we already have, the one with the Q, the I, the T, the V, the E, and all those stuff, right? So adding on top of that, we already have the V and the I from the chart. Now we're adding this one new thing called resistance, symbol of R, measured in ohms. As I said, if you recognize the unit, it's helpful for you to find what the symbol is, right? The higher the resistance, the more energy is required to push the current through it. So basically, the higher the resistance, the slower the current will be. All right, so let's do an example together. A heating coil has 12.5 amps of current passing through it when it's connecting to an outlet which produces 120 volts. Calculate resistance. Okay, so if something is measured in 12.5 amps, and say if they didn't even say the word current, if you have the chart made, all you have to do is look at, something that's measured in amps, it is I that I'm talking about. See how it's so helpful to have that table with you. Then you recognize the unit goes with the symbol. Okay, it has 120 V. What's measured in V? Go back to your table. What's measured in V? Voltage. Okay, so capital V. I'm looking for R. Okay, so what does R equals to? So what's the equation? So just now we already did that. R is V divided by I. Write out your equation. Remember, this is your 1 mark, right? Always write your equation out first. V is 120 volt. I is 12.5. It does matter what goes at the top and what's at the bottom, right? So punch it in. 120 divided by 12.5. I got an answer of 9.6. And if you don't remember, go back to your table. What's R measured in? It's measured in ohms. Some of you don't like to rate your unit and lost a lot of marks on your test. Make sure you do the plugged in. Make sure you do the answer. You would lose half a mark if you're missing unit. Okay? All right, so remember.